Hey everyone, welcome to the pre-lab video for our second Equilibrium lab of the semester. This week we'll be investigating shifts in chemical equilibria that we can bring about by doing chemistry, right? Can we add things to solutions that will shift the equilibrium between products and reactants? And so we're going to track these shifts in equilibrium by using solutions that change color by having products and reactants that are different colors from one another. Right, before we dive into some of the topics to help you prep for lab, just want to quickly go over the safety hazards that you can expect this week. We'll be using Bunsen burners, and so there will be open flame in lab. So fire is our first one. You'll also be using strong acids, which can corrode your clothes, your belongings, and damage your skin. And finally, we'll be using solutions that contain some heavy metals, which should be disposed of in the heavy metals toxic waste containers. These ones, like all chemicals, you especially do not want to ingest them. All right, we're going to get into a very quick kinetics review to get you ready for lab this week. And we're going to use an example here of nitrogen dioxide, NO2. This is the gas that gives polluted air its brown color. So one of the ways that you get NO2 out of the air is you react it with a hydroxyl radical, and that makes nitric acid as your product. Right? And the rate expression for this reaction is a rate constant K. We're going to make things simple and pretend that the rate constant K is just equal to 1 today. K times the concentration of NO2 times the concentration of the hydroxyl radical. And the way that this rate expression works, there are multiple combinations of the NO2 concentration and the OH concentration that can give you the same rate. So for example, if you have 2 molar NO2 and 1 molar OH using our pretend rate constant of 1, the rate is then 1 times 2 times 1. It's 2 moles per liter per second for nitric acid production. Right. We can get that same rate of 2 moles per liter per second if we have 1 mole per liter of NO2 and 2 moles per liter of hydroxyl radical. Similarly, if we have other combinations, 5 and 0.2, all of these combinations, look at me go, making nice mistakes. And all these combinations of concentrations will give you a reaction rate of 2 moles per liter per second. Right. And so in the questions here for this pre-lab, we'll ask you to come up with some other combinations of concentrations that give you same rates. And we'll also ask you to look at, give you some concentrations and ask you to predict which reaction will be proceeding at the fastest rate. The other concept we want to touch on heading into lab this week is the idea that heat itself can be the product of a chemical reaction. And one example of this is the way that you can use these hand warmer packets to just have a nice source of heat on you to help stay warm. Right? So what these packets are doing is they're taking solid iron, it reacts with oxygen in the air to make this iron oxide. Right. And more importantly, from your perspective, it also puts out quite a bit of heat. Right. And so when you do this chemical reaction, one of the products you get from it is heat itself. Whenever you get heat out of a reaction, we call that an exothermic reaction. Right. Heat can also be a reactant in a chemical reaction. Some reactions need heat as input in order to get you to your product. Right? You need to heat up things that you cook to get your edible food. And these types of reactions are called endothermic reactions. And the way that I remember definitions of endo and exothermic, right? Therm, this is just thermal temperature, heat, and endo right? This is the one where you have to put in heat. Endo in. It's the one you have to put in heat to get it to go. And so in the pre-lab questions, we'll ask you to figure out whether a given reaction is endothermic or exothermic. We'll also ask you for an example of these types of reactions from your lives. All right. That's all I have for you here. I'll see you all in lab this week.